of laws of motion, which is one of the utmost important topics in the IIT JEE syllabus. Let's first discuss the introduction to this topic. As it was discussed by Aristotle, a Greek scientist, he discussed about the various forces that can exist on a body. He discovered that there are two types of forces mainly. One can be classified as the external force and the other can be classified as an internal force. External force are the forces which act externally to a body. Now any type of force can be classified as either balanced force or an unbalanced force. Balanced force are the ones in which the net result of the force acting on a body is zero. Here, as we see in these examples, we have examples of balanced force as well as unbalanced forces. We have specifically mentioned wherein we have unbalanced forces. As we see from the slide, that in case of an unbalanced force there is a motion, whereas in case of balanced force there is no net motion. So if we classify that based on the net force, whether the body is in motion, it's moving uniformly, or is it not moving uniformly, we can draw a few graphs. As we can see on the graph, we have three types of graphs. One is a straight line graph, other is a downward sloping graph, other is an upward sloping graph. So what does that mean? It implies that in a straight line graph the body is moving uniformly, whereas in case of a downward sloping graph the velocity is decreasing and hence the body is retarding. That is, there is some net force acting on the body. Whereas in the third case, as we see, the body is accelerating as the velocity is going up with time. Now based on this we have classified the forces. Let's see the case of a sledge. Here a person can be seen on a sledge. As the person accelerates, he can move forward. Let's say, how can he move forward? There is a force acting on the body because of which the body moves forward. Here we have classified the various forces as there is a force of normal force, there is an internal force as well as an inertial force. Okay, so we have discussed all the types of forces that are acting on a body. Now let's discuss it in a little more detail. So we go over to the Newton's laws of motion. Let's begin with the Newton's first law, that is the law of inertia. It says that a body continues to be in a state of rest or of uniform motion unless an external force is applied on the body. Then goes the inertia of rest. That is, a body will continue to be at rest, or there is an inertia of motion, that a body will continue to be in motion. Let's discuss an example based on that. Here we have an example of inertia of rest. Let's say we keep a coin that is stationary on a glass. If we click on the pad, the coin falls down because of it being at rest, whereas the cardboard goes away. This shows the case of inertia of rest. Now let's discuss the inertia of motion. There is a body which is moving in forward direction. Here the body is accelerating because there is a force acting on the body. Now we have the inertia of direction. What does that mean? That is, here we are applying a force because of which the body has some inertia in a particular direction, or it is acting on a particular direction. Let's say for the given example of a body or a car, let's say, which is moving on a slanted road. The force acting on this body is acting towards the center. So here we discussed about the Newton's first law of motion, which was also known as the Newton's law of inertia. Now let's go over to the case when the body is actually acted upon by a force. This force presents us with the Newton's second law of motion, or which is also given by F equals to ma. What he thought was that there is an apple which is stationary on the tree. how does it fall on its own towards the ground? And if it has to fall, why does it at all fall towards the ground and not go above the ground? Based on this, he discussed the case of gravitational force of attraction. Now let's go a little more detail about the Newton's laws of motion. Firstly, we have all the three laws mentioned here. First law goes as the body continues to be in a state of rest or of uniform motion unless we apply an external force to it. Second law goes by the form that if there is an external force applied, it accelerates the body. And the third law goes as the law of action and reaction, that if there is a body which is acting a force on the other body, then the other body gives back the force to the initial body, that too in a reverse direction. Finally, we also now go over to the Newton's first law of motion in detail. We have already discussed where and how we can apply the Newton's laws of motion. The first law is stated as in therein, these bodies are at rest and will continue to be in a state of rest unless we apply an external force. So all these bodies deal with the first law of motion, that is the law of inertia. In the second law, we have the Newton's second law of motion, where if there is a body that is acted upon by a force, it will accelerate. It can accelerate either towards the ground, for example in the case of apple falling towards the ground, or it can accelerate as in the case of an aeroplane. Let's discuss more on the Newton's second law of motion. We define the momentum as the mass times the velocity acting on the body. This is defined as momentum, and we also define that the change in momentum is equal to the force acting on the body. Now let's discuss something based on the momentum experience. We all must have come across this simple example of a cricketer running in a field to catch a cricket ball. Why does he have to fold his hand and go in a forward direction after catching the ball, as well as take his hands downwards? The reason being, the cricket ball is coming with a large amount of momentum. So when it lands on the hands of the cricketer, what happens? There is a large amount of transfer of momentum to the hands of the cricketer. To reduce the impact of the momentum, what we do? The cricketer actually takes the hands to as much distance as possible towards the ground, and thus reduces the impact of the force created by the ball. Here we discussed about the second law of motion. Now we are going to discuss about the Newton's third law of motion, which is also known as the law of action and reaction. Let's put some air in a balloon. What happens because of that? The balloon goes up and it starts ejecting air in the downward direction. So the amount or the force acting in the downward direction because of the air coming out is equal to the amount of the force acting to take the balloon in the above direction. Here is a simple example which shows the following. The air gushing out of the balloon towards left side and the balloon going towards right. So action is the air going towards left and the reaction is the balloon going towards right. Similarly, we can consider the case of a horse and a cart. Here, the horse exerts a force in the forward direction and the cart exerts a force in the backward direction, thus to pull the cart. Next goes our case of a gun. What do we have in the case of a gun? When the gun recoils because the bullet has come out of the gun, what happens? There is an action produced by the bullet coming out, as well as there is a recoil produced by the gun going in the backward direction. Now let's discuss the case of conservation of momentum. The conservation of momentum goes as if there are two bodies that are colliding with each other. In that case, there will be total initial momentum of the bodies, as well as after collision there will be final momentum. The bodies need not be moving together, it may move separately. When they move separately, we can say that there is a kind of elastic collision, whereas if the bodies do not move separately, we say that the bodies are moving with an inelastic collision. Okay, so here we have discussed the conservation of momentum